Like I said, it's a long lesson today, so bear with me. Okay, so today we're going to learn actually 3 different types of graphing. And I would say they go in, the first one is the hardest, second one's about the middle, and the last one's the easiest, okay? So the first one that we're gonna do is called piecewise functions. And so those of you at home, you're gonna have to bear with me and stick with me because this is all different that we go through. So with piecewise functions, what happens is they'll give you the function like this, okay? And g of x equals x plus 4 for all x's less than 4. So, or I'm sorry, less than a negative 4. So from here to here, they are using this equation, okay? Then in the middle of the graph, they're using this, 2x plus 5. And that goes from x is a negative 4 right here to x is 1 right here. Okay, that is this line. Now notice the blue line here has an open circle. That is because this is just less than. It's not less than and equal to. Whereas this middle orangish red line has closed dots at both ends, and that is because if you look, the signs are both less than and equal to. Then above x equals 1, which is here, we're going to follow the green line, and that one has an open circle because of the fact that it's just greater than. Now, this I kind of stole from somewhere online, and our domain, we're going to write a little bit different than they've had it in what's called interval notation, and we're not going to write it like that. Now, when you do your domain and range for today, your domain means what x values is your function defined for. And everywhere you go, like when you notice here, there's an open circle, that might make you think, oh, it's not defined there. But if you go down, that point is defined here because there's a closed circle. Then when you go across to 1, notice one of them is open, one of them is closed. And that'll always be the case. You'd never have a case where they're both open or they're both closed, okay? And then when you go across the rest of the way, this green line is going to cover all those points. So your domain for every single one today is going to be all real numbers. Your range is going to be more difficult to find. So one thing you have to think of here, this line and this line are going to keep going forever and ever. So this is defined, when you're doing range, you're thinking about what y values is covered on your graph. All of these are going to be covered because these lines are going to keep going forever and ever, okay? Where we have an issue is still up to this point, we're good. Up to the top of the green line, we're good, because we have all of those y's covered. And then you notice the red takes over up to this point. But this, notice, does not have an arrowhead. This stops right here. So that is the last y that has a point. And if you notice here, we're counting up 1, 2, 3, 4, 5, 6. So this is 7. So our graph is good for all y's less than or equal to 7. And how you write it instead of y is whatever this is. You write for all g of x less than or equal to 7. The reason it's equal is because this is a closed dot. If it was an open dot, it would just be y is less than 7. Okay, that will be a little bit hard, but we'll go over many examples like that. Okay, now this next one, when you do this, you're going to have 2 or 3 lines each time, and this is called your constraints. Okay, so our constraints for this one, there's only one of them, and it's at -1. So what I do, and what you may find helps, is at -1, I put a vertical line, and if you can make it a little bit different color, so you know that's kind of where the graphs are going to be different, starting at and going from. So that's where my lines are going to start and stop. Now, for all x's less than -1, we are going to be doing the line f of x equals x minus 2. Okay? Now, that's in slope-intercept form, and that tells us our slope is 1/1, and our y-intercept is -2. Now, you want to use a pencil that is easily erasable when you do this. So what you would do is you would go down to -2. And if I was graphing this entire line, my slope is up 1/1, so I would keep going like this. However, this is the issue. This graph only works for x's less than a -1. So from this green line and to the left. So what I want to do is use that same slope, but go in the other direction. So I'm going to go back to -2, and instead of going up 1, right 1, I'm going to go down 1, left 1. Okay? And then I'm going to keep doing that. Down 1, left 1, down 1, left 1, down 1, left 1. And that's where I care about the line. I can go back now and erase these points because that's not in the area that I want it to be. And the point that starts on my green line, I have to look here and see, should I have an open circle or a closed circle? Do you guys get that this should be open, right? And then you're going to go down like this. Okay, so now I did half of it. Now what I have to do is do that other line. Okay, so what I'm going to do now is graph f of x equals x plus 3. My slope is what's in front of the x, which is 1/1. My b is my constant, which is 3. So I'm going to go up to 3. And now my slope is up 1/1. And this one I can continue. Okay. But notice I want to start it on the green line. So I'm going to want to go down 1, left 1 to see where I started. And I'm not sure if that's going to be an open circle or a closed circle. And the thing is, it's going to be closed. Okay. So I'm going to make a closed circle here, and it's going to look like that. Okay? So here's...
Why did we go to the right that time?
Because it was for all x's greater than or equal to -1. So that means like it's in this region over here. Okay? Good question. So now, if you notice along my green line, you should always have one point that's closed and one point that's open. So we did that correctly. And now I have to write what my domain and range is. Every single time today, your domain is going to be all real numbers. So you don't even really have to think about that one. Okay? Your range is your y's. That one's a little bit difficult. Do you guys see that this graph is like this much down here? And this graph is up here, right? So I'm going to have 2 different sections that I have to explain. So this bottom one, I'm going to use the f of x, which is really just like saying y. And this down here is going to be for all y's. This is a -3. So do you guys get that it's going to be less than a -3? And it's not equal to -3 because that is open. Okay? Then when I go to describe this top one, I'm going to say or f of x is greater than, okay, from 2 going up, okay? And is this one just greater than, or would it be greater than or equal to? Equal to 2. Do we get it? Okay. So now let's go here. This one has 3 lines. And with 3 lines, what you're doing is you're looking at where should I draw these vertical green lines. And it's going to be at the points that they're saying here. So I'm going to have one that I'm going to put, whoops, I got to put this down. I'm going to have one that I'm going to put at x equals -6, right here. And I'm going to have one that I put at x equals 2. Okay? So now here, once you do that, you have like one region here, another region here, and another region here. In region 1, you're graphing this. In region 2, you're graphing this, and in region 3, you're graphing that. Okay? So for region 1, we're graphing g of x equals that first one, 2x plus 2. My slope is 2 over 1, and my y-intercept is 2. So if I went to 2, do you guys get that I don't really need to go up to right 1? Because do I want my line to go up and to the right? Don't I want it to go back and to the left? So instead of going up to right 1, I'm going to go down to left 1. That's the same thing. Down to left 1, 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 down to left 1. Okay? Now, do I need any of these in between the 2 green lines? No. That's in region 2, and we'll be graphing there later. What I do need is just these 2 points way down at the bottom. And the first thing I have to decide is that first point on the green, should it be open or closed? Open. And then you can just do this. Okay, so that is your point. Now, now I'm going to go to region 2. And region 2 is going to be for the line f of x equals x. Okay? Like I said, that is like y equals x. So our slope would be 1 over 1. Our y-intercept would be at 0. Okay? So you'd start at 0, up 1 over 1, up 1 over 1. And do you agree it doesn't make sense to keep going to the right? But I do need to fill in between the 2 green. So I'm going to go down 1 over 1, down 1 left 1, down 1 left 1, and keep going. Okay, just so I'm in the area in between the 2 greens. Now, if you look at this sign and this sign, should these be open or closed? Closed, both of them. So there should be like an emphasized closed on either end, and then connect these dots. That's my second line. Then my third line is this bottom one, which is g of x is equal to a -3. That is a horizontal line. That is like y equals -3. So you would go down to -3, and we would do a horizontal line. Okay, and I know I just want to be in region 3, so I'm going to start it right at this point, but I have to think about that point right on the green line. Should it be open or closed? What should it be? Open, good. Okay, so that's my graph. Now I need to do my domain and range. So my domain is always going to be all real numbers. And now we have to describe where we have y's that are covered. Do you guys get that from -10 and below, this graph would keep going and going? So that is going to be for all g of x's, which is like our y, less than a -10. And do you agree it should just be less than because this is an open circle? Okay. Then we're going to go or. Now, do you guys get that this purple line is kind of included in the pink line? Okay, so if I just wrote one for this pink line, I can ignore the purple. Now, you want to talk about from what y value, like here, are you going to up here? What y values are covered, okay? And so in the middle is going to be your g of x, less than and less than on either side. And you put your smaller of your y values here and your larger of your y values here. And then you're going to ask yourself, should they be equal? With looking that they're both closed, do you guys get they should both be equal? Okay. And that covers all of our y's that we need to represent. Questions on that?
So we don't need to represent 2.
I think the only ones we ever have are 2 or less.
Okay.
So sometimes it's just 1. I don't think you'll ever have 3 for the range. Yep. Okay. So let's go to this one. And again, you have to decide, like, where am I going to draw those vertical lines? You want one to be at 0 and one to be at 2. Okay. So I'm going to move my little lines, one at 0 and one at 2. Okay. Now, here's the deal. I am going to, first of all, do f of x is equal to x plus 2. So like again, I have 3 regions here. I have 1. I have a really skinny one right here for the second one, and then I have 3 over here. First, I'm doing that first region, which is where x is less than 0. And this is x plus 2, so my slope is 1 over 1. My y-intercept is 2. So if I go up to this 2, do you guys get that I would need an open circle there because that is just less than? And normally I'd go up 1, right 1, up 1, right 1, but I only want to go off to the left. So I'm going to go down 1, left 1, down 1, left 1, and keep that going. Now, one thing I did not talk about that I should say before I forget, I think yesterday I was talking about the fact that I wasn't sure what I was going to do with the quiz for the B students. So here's what I thought. Today's lesson is pretty long, and tomorrow and Friday, I have some kids missing. So what I did is tomorrow I'm just giving you guys a work day to do today's assignment, okay? And then Friday, you're going to do a practice quiz. If you're taking your quiz during this hour, just make sure that you get that from me so that I can give it to you, and I'll have to get one for you, okay? All right, now let's go to the second part and do f of x equals 2x plus 5. where our slope is 2 over 1 and our y-intercept is 5. Now this is that tiny little one in the middle. We're going to go up to 5. And notice here on both sides, we have closed. So just so you know that, right now that one I really don't have to worry about. But my slope should be up 2 over 1, and that would be closed on that green line. I could keep going, but I don't really need to go into region 3. So up to right 1 is the same as down to left 1. And these endpoints I'm going to connect. And because this side and this side are less than or equal to, that makes those two endpoints closed. Okay. Then I'm going to go to my last one, which is negative x plus 1. My slope is negative 1 over 1. My y-intercept is 1. Okay. So I'm going to go up to 1.
Wait, how did you get down to 3 there? I think you started at 1 to the right. Because like the numbers are to the right of 0.
Oh, yeah. I'm going to have to switch this graph out because I did the same thing first hour today. I think sometimes I get confused when I put this as my x-axis, but you are correct. I should be at 5, right? And then it goes up 2 over 1. So I don't even have to go down 2 left 1, right? And then up 2 over 1 like that. Thank you. Yes. Okay. Now if we look at our last one, we have a slope of negative 1 over 1, and it crosses the x-axis at 1. And I can go down 1 over 1. I could put a little dot there. I'm not going to end up using it. And then a dot here, down 1, right 1, down 1, right 1. And I can just keep going down. And I'm not hitting the points very good. So I am going to have a line like this. Okay. And I have to decide if this point right here should be open or closed.
Open.
It's supposed to be open because that is just greater than. So just make a big circle there. Okay. Now we have to do the domain and range. So again, your domain is just going to be all real numbers. And your range, you want to look at what y values are covered. Do you guys get, if I look at this pink line, that covers all y's below negative or below positive 2, right? And that covers this line too. So that would be f of x is less than, not equal to, because this is open, less than 2. Do you get that? Or, now for this purple line, we just give the range that it's at, and it starts at 5 and goes to 9. So you would say, or 5, and then f of x in the middle, 9 here, less than, would these also be equal to if these two are closed circles? Yes. You get it? Everybody okay? That's the hardest part, I think, for today. We'll see what you guys think. Okay? So now I'm going to go to something that I don't think you guys have seen before. It's called a step function. And you're going to get something inside of what looks like a double bracket. And what that is, it's called the greatest integer function. And what you do is you would, whatever number they put in there, what the greatest integer function is what number, what integer I should say, is less than or equal to this. Now integers are like -2, -1, 0, 1, 2, 3. What is the greatest integer that's less than 0.5? So you know how 0.5, if we look on a number line, isn't 0.5 like right here? So you're looking for what integer is less than that. Wouldn't it be 0? Do you get that? Okay. If you're at 1.75 right here, what's the greatest integer less than that? 1. If you're at 2.3, what's the greatest integer less than that? 2.
Is it only whole numbers?
It's only whole numbers, but they can be -2. Okay? -0.5. Now this one's a little bit different.
0.
A lot of people would say 0, but you're looking for what is the greatest integer less than that. So back from it, wouldn't it be -1? Okay. If you're looking at -2.5, what's the greatest integer less than that? -3. And if you're looking at -4.6, what's the greatest integer less than that? -5. Very good. Okay. We're not going to talk about absolute value yet. We're going to just keep going with this. So what we're going to do is learn how you graph a step function. When you graph a step function, you're going to have stairs on your graph or steps on your graph. And generally what happens is one of your stairs would be from 0 to 0.99. Then you'd have one from 1 to 1.99. Then you'd have one from 2 to 2.99, 3 to 3.99, and so on. And you want to do enough of those until you can find a pattern and kind of continue those stairs throughout the graph. So when I make these, I then take the whole number and I put it up into this equation. Well, if that's already a whole number, the greatest integer less than or equal to 0 is just 0. So 0 times 2 is 0. 0 minus 4 is a -4. Do you get that? Okay. Now I'm going to take the whole number again, the 1, and I'm going to put it up in here. If it's a whole number, the greatest integer less than that is just itself. So this would just be 1. Times 2 is 2. 2 minus 4 is a -2. Okay? If I put 2 in there, the greatest integer less than or equal to 2 is 2. 2 times 2 is 4. 4 minus 4 is 0. Okay? If I put 3 in there, greatest integer less than or equal to 3 is 3. 3 times 2 is 6. 6 minus 4 is 2. Are you seeing a pattern there? It's just going up by 2 each time. So this is how you graph this one. It is -4 from 0 to 0.99. So we would go on our graph down to -4. We put a closed circle at 0. We put an open circle at the end of that because 1 is not included. And we put that step right there. Then we're going to go to, I should just stay with the same foot. From 1 to 1.99 is like the area from 1 to 2. I'm at -2. I always put a closed circle on the left, an open circle on the right, and I connect it. Then I go to 0, and that is from 2 to 2.99, so I just put an open circle and I connect it. Then from 3 to 3.99, I'm up at 2. Closed circle, open circle, connect it. And then you have to keep going with that. So you want to kind of find a pattern. If you go from your open circle, up 2 would be a closed circle, over 1 would be an open circle. If you go up 2, closed, over 1, open. Go from the open circle, up 2 is closed, over 1 is open. Up 2 is closed, over 1 is open. Same thing going down. This one you'd go down to left one, and that would be my closed. Open would be here. Down to left one is closed, open is here. Down to left one, open is here. Does that look right? So they should look like stairs coming down. Okay, everybody okay there? Now your domain again is going to be all real numbers. With your ranges for a step function, it's either going to be all odd integers, all even integers, or all integers. Now notice we have -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, 10. That's all even integers. That would be my range. If they were at the odd numbers, you would say all odd integers. If you had one at every single one, then you'd say all integers. Okay. So let's go here. This one is a little bit different because you have two things inside of there. So again, I'm going to go 0 to 0.99, 1 to 1.99, 2 to 2.99, and 3 to 3.99. Now again, I put the whole number in there. 0 times anything is 0. 0 plus 4 is 4. The greatest integer less than 4, less than or equal to 4 is 4. 4 times 2 is 8. Okay? Then I'm going to put in 1. 0.5 times 1 is 0.5 plus 4 is 4.5. And then I still have that 2. Now, what is the greatest integer less than or equal to 4.5? 4. And what's 4 times 2? 8. So sometimes you'll have 2 in a row that are the same. Okay. Now let's go to 2. If I put 2 in there, half of 2 is 1. 1 plus 4 is 5. The greatest integer less than or equal to 5 is 5. 5 times 2 is 10. Now we're going to put 3 in there. 0.5 times 3 is 1.5. 1.5 plus 4 is 5.5. Now, what's the greatest integer less than or equal to 5.5? 5. What's 5 times 2? 10. What would you guys guess we would get for this one and this one? Yep. Okay, so let's go ahead and graph this. So from 0 to 1, we would be up at 8. It's always closed on the left, open. Oh, but here, you know how last time we went over just one square? Here we're actually going from 0 to 1, and from 1 to 2 are both 8. So we're actually going to go from 0 all the way over to 2 and connect it. So because from 0 to 1 and from 1 to 2 was 8, I just draw over 2 squares. Now notice from 2 to 3 and 3 to 4, we're at 10. So we'd go up to 10 and go from 2 over to 4, like that. Now those 12s really are off our graph, so we don't really care about that, but we again want to find a pattern. If I started at this closed dot, notice if I go down 2, left 2, I get to a closed dot. So let's start at a closed and go down 2, left 2, put a closed dot. Over 2 to the right is an open circle. Start at your closed, go down 2, left 2, that's your closed dot. 2 to the right is open. Start at your closed, down 2, left 2 is closed, open. Down 2, left 2, closed, open. Down 2, left 2 is closed, open. Okay. Now we have to give the domain and range. So our domain is always going to be all real numbers. And our range, anyone want to take a guess what it would be? Because remember, this stair would keep going. Yeah, Tila? All even integers again. And they can end up on odd, so don't think it's always even. You can get ones that are odds too. And you can get ones that are at every single integer, and then you say all integers. Now we're going to go to our last time. We have 2 more problems, okay? This one is what I think is the easiest. You may not, but what I do for this to start is I look at what's inside of my absolute value, and I set that equal to 0, and I solve it, okay? So I'm going to subtract 1, and 2x is going to equal a -1. We're going to divide by 2, and x is -1/2. What that tells me is at -1/2, a graph of an absolute value function is always a v, okay? So that -1 is where your x value of that v is going to be. So when I make a table, I'd put the -1/2 kind of in the middle, and then I would go 1 integer below it, which would be -1, and then maybe 1 more. And then I'd go 1 integer above it, which would be 0, and 1 more, okay? And then what I'm going to do is I'm going to put these in. Now remember, that's absolute value. So whatever is inside, you make positive. So 2 times -2 is -4, plus 1 is -3. Absolute value of a -3 is 3. Then if I put a -1 in there, 2 times -1 is -2, plus 1 is -1. Absolute value of -1 is 1. For -1/2, 2 times a -1/2 is going to give me a -1. -1 plus 1 is 0. Absolute value of 0 is 0. And that we kind of knew because when we set this equal to 0, we got x equals -1/2. Now if I put 0 in here, 2 times 0 is 0, plus 1 is 1. Absolute value of 1 is 1. Then if I put 1 in here, 2 times 1 is 2, plus 1 is 3. And do you see how these 2 are equal and those 2 are equal? That's nice if you can figure out where your V vertex is and go the same distance on each side. That should happen. So now we're going to go ahead and graph those points, and we should get it to be in a V. So at -2, we're going to go up to 3. At -1, we go up to 1. At -1/2, we're going to be at 0. At 0, we're going to be up at 1. And at 1, we're going to be up at 3. Now, if you have a ruler, which there's rulers here from when you do your assignment, you really don't have to come up with other points because these are going to lie on a straight line. So you're just going to connect these dots, okay? And then you're going to start here and connect these dots. And if you have a ruler and you do straight lines, it should be a V when you're done, okay? And then we have to say our domain and range again. So our domain, again, is always going to be all real numbers. And our range, does anyone want to guess what that would be? F of x is, this would be all positive integers, which we could write as f of x. It would actually be all positive numbers, but the way you'd write it is f of x greater than or equal to 0. It's all of your y values, and it's equal to 0 because we have a point there. Everything greater than or equal to 0. Okay. Last one. Now again, how I would start this one is I would take what is in that absolute value, just the x minus 2, and think what would I get when I set that equal to 0. So x is 2, and I'm going to put that right here in the middle. And then I'm going to put 2 numbers less than it and 2 numbers bigger than it. Well, less than 2 is 1 and 0. Bigger than it is 3 and 4. And you can always add more than that too. So now I'm going to put 0 in there. 0 minus 2 is a negative 2. Absolute value of a negative 2 is 2. 2 times 3 is 6. 6 plus 1 is 7. And I'm going to put 1 in there. 1 minus 2 is a negative 1. Absolute value of a negative 1 is 1. 1 times 3 is 3. 3 plus 1 is 4. I'm going to put 2 in there. 2 minus 2 is 0. 0 times anything is 0. 0 plus 1 is 1. I'm going to put 3 in there. 3 minus 2 is 1. Absolute value of 1 is 1. 1 times 3 is 3. 3 plus 1 is 4. If I put 4 in there, 4 minus 2 is 2. Absolute value of 2 is 2. 2 times 3 is 6. 6 plus 1 is 7. So again, notice these two are the same and those two are the same. So now I'm going to go ahead and plot those points over here. I have 1 at 0, 7. I have 1 at 1, 4. I have 1 at 2, 1. I have 1 at 3, 4. And I have 1 at 4, 7. And then, like I said, if you use your rulers or some type of straight edge, if you're at home, draw 2 straight lines, and that is our B. And now we're going to say domain and range, okay? Our domain is going to be all real numbers again, just like it's always been. Does anyone want to guess what our range would be? It would be f of x greater than or equal to 1. Perfect. Okay. So again, tomorrow I basically am buying time for people to take the AccuPlacer. So if you are home tomorrow and you have time, and you have, do any of you take the practice quiz or take the AccuPlacer on Friday during this hour? Anyone? No? Okay. Then you guys can just work on the practice quiz in class. If somebody at home has to take the practice quiz or takes the quiz on Friday, I guess, no, you guys will all be here tomorrow. But if you're going to be gone tomorrow, you just have a work day. You still have to check in with me and do attendance, but then you really just have a work day on what we're doing today. Friday, if you wanted to get a head start on that, the quiz is right here, the practice quiz. I don't know if I put these in your folders or not, but if I didn't, if you don't have it, feel free to grab it. If you want to just wait till Friday when you're here, that's fine too. This is your assignment for actually Friday night now. And then those of you at home, I'm going to wait for them to copy this down, and then I'm going to show you where the practice quiz is if you wanted to get a head start on it. But actually, you guys would be here tomorrow in class, and I could give it to you in class tomorrow too. So if you got your assignment done tonight, you could take your practice quiz in school tomorrow, and then you wouldn't have anything on Friday. But then remember, next Monday, A students have a quiz, just like the practice quiz. Tuesday, B students have the quiz. Do you guys have any questions for me? I will take you to Schoology super quick.
I got a question.
Yeah.
If we're gonna be in your class tomorrow for the practice quiz, we don't have to do it online.
Right. You could get it done tonight if you wanted to and do the practice quiz in class tomorrow. tomorrow really nothing's due, you get a work hour. Okay? So you
And then-
could either use tomorrow to do today's assignment or to do the practice quiz.
Do we have to do the other study session tonight for the ACT?
For AccuPlacer, yes. It's your first time, I strongly suggest you do that because most people get bumped into the second test. And you might as well try to get a good grade on it so you don't have to take it again. So I guess if I were you, I would. Okay, so those of you that are looking here, if you go, oh boy, my mouse is doing crazy things. If I go down to chapter 2 and go to assignments, I did put in, so today's assignment is this page 122. And then the practice quiz is what I'm assigning on Friday, really. That's due Sunday night. Today's assignment is due Friday night. You'd have tomorrow to work on it in class if you want. And then Friday is the practice quiz. That's due Sunday night. If you go in here, if you want to get started on it, you can go in here and the practice quiz is here. You can open it up. And there's also a key to it if you wanted to get started on it. Okay, I will go back to my assignment. Anyone else at home have questions for me? Say that again. Oh, yeah, actually I have it set up for Schoology for Sunday night. So you'll have to take pictures and upload it in there. Yeah. Unless if you got it done, because you guys would be here Friday and you'd rather hand it to me, that would be fine and I could put it in. It's kind of up to you. All right. Once you guys get that assignment done, if you don't have any questions, you're free to go.